Welcome to another problem solution with the physics tutor. This will be from Giancoli's 7th edition of physics, chapter 11, problem number 6. The problem reads as, a small fly of mass 0.22 grams is caught in a spider's web. The web oscillates predominantly with a frequency of 4.0 hertz. A. What is the value of the effective spring stiffness or constant K for the web? B. At what frequency would we expect the web to oscillate if an insect of mass 0.44 grams were trapped? Okay, so we've got a fly with a specific mass and we have got a spider web that is oscillating. We're going to assume that we're going to model the spider web as a spring, as they're asking for the effective K value of the web, and the fly is our mass of 0.22 grams, and we're oscillating up and down, or back to forth, however you want to think of it, with a frequency, they tell us, which is equal to 4.0 hertz. So here's our fly, here's our web. Our fly has a mass of 0.22 grams, and it oscillates back and forth while attached to the web at 4 hertz. In other words, 4 times a second it oscillates back and forth. And what they would like to know is, what is the K value of the web if we imagine the web to be a spring and the fly to be a mass attached to that spring? Okay, so the relationship that we can use to solve this, and we've used it in other problems, we know that frequency is equal to 1 over 2 pi times the square root of the spring constant K over m. We're going to solve for K. We know m and we know the frequency. So we would have, first off, moving 2 pi from the right-hand side to the left-hand side, multiply by both sides. I would say 2 pi times the frequency is equal to the square root of K over m. I'd like to isolate K, so I'm going to square both sides, and that will give me 4, 2 squared, times pi squared, times the frequency squared is equal to K over m. And then lastly, I'll multiply both sides by m, so I isolate K, and I get 4 pi squared f squared times m is equal to K. And now I know all of these values. I know the frequency is 4 hertz, and I know the mass is 0.22 grams. Before I plug the mass in, though, I want to be in kilograms so that this comes out as newtons per meter. So I will do 0.22 grams times 1,000 grams per 1 kilogram, which gives me a mass for our fly of 0.00022 kilograms. And now we're ready to plug in. So we would have 4 times pi squared times 4.0 hertz squared times 0.00022 kilograms is equal to K. We can plug this into a calculator, and we would find that K is going to be equal to 0.139 Newton meters, or roughly 0.14 Newton meters when we round to the correct number of significant figures. 4.0 has 2 significant figures, 0.22 has 2 significant figures, so our answer should have 2 significant figures. That's the answer to part A. In part B, what would the frequency be if the fly had a mass of 0.44 grams? 0.44 grams. Notice we're doubling the mass in this case. Well, it's not a big deal. Because we know the K value, we can simply go ahead and plug the mass in and the K value we just solved for in our frequency relationship, and we can solve for this new frequency. So frequency is equal to 1 over 2 pi times the square root of K over M, which in this case would be equal to 1 over 2 pi times the square root of 0.14 Newton meters divided by our new mass, which will be 0.00044 kilograms, just doubling the mass from the first problem. And when you run that through your calculator, you'll get 2.839 hertz, which we will round to two significant figures again to get 2.8 hertz. Now, a little something that's interesting here. If you think about this, what we did is we doubled the mass. We multiplied 0.00022 kilograms by 2 and to get 0.00044 kilograms. If you look at 2.8 hertz compared to 4 hertz, 4 hertz divided by the square root of 2 gives you 2.8 hertz. By doubling the mass and not changing springs, we've reduced the frequency by a factor of the square root of 2, which is to be expected because that's the relationship between frequency and mass. As mass increases, frequency decreases. If we double the mass, frequency will decrease by 1 over the square root of 2. If you found this video helpful, please like and subscribe. And as always, remember to enjoy physicsing, and I'll see you guys in the next one.